Suppose we're given a triangle and we're given two sides and we asked to find the angle in between. Okay, so there's my right angle triangle and I'm given an unknown angle x. I'm also told that the opposite side length is 23 and I'm told that this length over here is 45. I want to find the value of x. So how do I do this? The first thing I have to do is identify the sides. I know that this side over here is opposite because it's opposite my x value. You can see that if I go opposite there, that's going to be my opposite side. This is my 90 degrees, so that's going to be my hypotenuse. So hypotenuse would be on this side. Now, if I have opposite and hypotenuse, remember I have to use sine because sine has opposite and hypotenuse in it, like that. So from this here, I would calculate it and say, okay, well, sine of x equals opposite divided by hypotenuse. And so that's equal to 23 over 45. Right? But at the same time, on the left-hand side, I'm going to keep sine x there. And I now have an equation. What I want to do is solve for x. So I keep x on the left-hand side and then move sine over. And when I move sine over, it becomes sine to the power of -1, or shift sign on a calculator. Then I put 23 over 45 on a calculator. And using the shift button, it should give me a really nice answer, or in this case, not really nice, but an answer, some kind of answer. So here we go. Grab a calculator, press shift and the sign button, open the bracket, and then put 23 over 45 on the inside. Okay, and then press equals. Make sure your calculator is in degrees mode, and there is a DEG over there. So the answer we want to get to is 30.74 degrees. Now we're going to get given another triangle. And in this triangle, we also want to find x. But this time we're given different sides. So we're given this side here is 43 and this side here is 55. For this, what we must remember is that the angle over here is adjacent and the angle over there, and the side over here is adjacent and the side over here is my hypotenuse. So this will be my hypotenuse. This over here will be my adjacent side. That's what ADJ stands for, adjacent. So if I go to my initial, we're going, okay, well, we've got our adjacent and we got our hypotenuse, so then we should use cos, because cos has the adjacent and the hypotenuse in it. So we use cos equals adjacent over hypotenuse. And let's type that in. So we write cos of x equals adjacent over hypotenuse. So that becomes cos of x is equal to 43 divided by 55. So therefore, x will equal cos inverse of 43 over 55. Shift cos. So that becomes shift cos on the calculator. 43 over 55. And the answer you get is 38.57 for this. All right, the next triangle, we're given two different sides again. So this is going to look like this. And in this triangle, we again given the same angle x on the side. given this side here is 12, and at the bottom over here is 20. Let's we label it opposite because it's the opposite side, and this is your adjacent because that's the adjacent side. So we have the opposite and we have the adjacent. Opposite is opposite there, adjacent is there. So which one should we use? We go back and say, okay, well, opposite and adjacent means that we should use tan because tan is opposite over adjacent. So we go back here and we write tan of x will equal opposite over adjacent. And tan of x is equal to 12 over 20. Tan of x means that now we're going to isolate x. We're going to make it equal to shift tan 12 divided by 20. X is equal to shift tan 12 over 20. So we go shift tan 12 over 20. .96 is the correct answer. Degrees, we can put a degree symbol. We can just stop there for that. One day. Okay, so that's how we use sine, cos, and tan. Now, sometimes the angle is on the other side. So let's suppose we're given this same triangle as previously, but let's move the x over to this side. Okay, if I move the x over to this side, then, and let's say I move this number over here, then this number is going to become, or this side is going to become the adjacent. And so when I'm doing this question now, instead of using sine, I have to use cos. No, I can still use sine for this one actually, but the opposite's on the other side. And it will give you exactly the same result like that. So when the angle is at the top, then this side becomes opposite. When the angle is at the bottom, then the opposite moves there, like that. All right, and this becomes adjacent. And then this side here, if this side is the opposite, then the other side becomes adjacent over here, from here. So it'll be, this is 45. Yeah. We can do the same thing for these. If I move x over here, then this side becomes adjacent on there. Let's suppose 43 was there as well. Then that will be my adjacent side from there. Hypotenuse stays unchanged. If I have to move x again across, then this side becomes opposite and this side becomes adjacent. We could leave the numbers there just to keep the accuracy the same. And we would use opposite over adjacent, so this would be adjacent over here, and opposite will be over here from here, like that. Okay, so we got sine, cos, and tan, and the x values can move around. If this x value moves around there, then remember this becomes opposite, and this becomes adjacent. But the hypotenuse stays the same. Hypotenuse is exactly the same. So in each of these numbers over here, opposite here will become 9, and then that will become 3. And then this will become 12, because adjacent is now 12, and that will become 4. Likewise, opposite over adjacent will flip over, will become 9 over 12, which is the same as 3 over 4. Okay, so when the x value is at the top, everything flips over the other way around.